Hello, today we're going to be doing one of the blind 75 LeetCode questions. If you are not aware of this list, it is basically a list of curated LeetCode questions put together by some knowledgeable person that has a lot of questions that are very useful to know if you're going to be interviewing. The question that we're going to be looking at in particular is detect cycle in a linked list. I've got it pulled up here. So we're told, given head, the head of a linked list, determine if the linked list has a cycle in it. And so a cycle, they say what it is here, but it makes more sense if you look at it visually. And so we have 3, it goes to 2, goes to 0, goes to -4, which points back to 2. So we have a pointer going to a node that's already in the list, and that is our cycle. We're also told about pause, and it's used to denote the index of the node that's tail next pointer is connected to. I'm not sure if they're trying to confuse us by not making any sense, but we're given a list node head. I don't think we need this pause parameter, and we're also not even given that pause parameter, so I really hope that we don't need it, but I think we can go without it. So you might be thinking, okay, I'll just iterate, have a while loop, traverse over the linked list per usual, while something like while cur.next is not equal to null, do something, update cur equal to cur.next, and then check maybe inside that for loop or that while loop, is cur.next equal to null? If it is, return false or return true because we don't have a cycle because we found the end of the list. Otherwise, continue doing that until we find the end of the list. So let's think about how that would work. We'd go here. It's not the dot next is not equal to null. Continue. Dot next is not equal to null. Okay, continue. We'd have an infinite loop because there's not really we can't tell. One of the fundamental problems is that we cannot tell if the program is going to halt. So we will forever be trapped in that while loop. That sounded pretty dramatic, but essentially we can solve this in a more clever way by using a fast and a slow pointer. And so I'll just go ahead and declare that here. And I'll just both point them to head for now. And so we'll have a fast and a slow, and basically we're going to have fast increment or go up the list at twice the speed as the slow pointer. So they'll both start out with 3, but then on the first iteration of our while loop, fast will go to 0 and slow will go to 2. Next, fast will go to 2 and slow will go to 0. If we think about it, we're guaranteed that if there is a cycle in the list, fast and slow will at some point meet. So we'll have a while loop and we'll say, well, fast .next or just .next does not equal null. We're going to increment fast by 2. That's how we keep it going twice as fast as slow, because we're just going to say slow is equal to slow.next. And then if fast equals slow, return false or return true, rather, because we know that we found a cycle. Otherwise, return false, because we know if we got here, then it must be the case that there is an end to this list. And now, because we're incrementing fast by 2 times, it is possible that fast itself could be null, the variable. So I'll say fast does not equal null, and fast.next does not equal null. And we have to put fast before this expression, or we have to put this expression before this expression in the conditional, because this one is more restrictive. And essentially, if this fails, then we won't even look at that. Java won't even look at that. So let's see if this works. We'll go ahead and run it first. All right, let's go ahead and submit. Cool. So if we think about the time complexity of this code, it seems a little confusing, and that's mostly because it is. We can think about like if there is not a cycle, what the time complexity is. It's going to be O of n because we're just going to iterate to the end of the list, and that'll be that. But if there is a cycle, we're going to have to do that kind of rounded about, looking at the fast and slow pointers and see if they equal each other. And basically, the number of times that can happen is equal to the length of the cycle, which is bounded by the length of the list. So therefore, our time complexity is going to be O of n. And looking at our space complexity, we create the fast pointer and the slow pointer, and that's basically it. So our space complexity is O of 1 or constant. Yeah. I hope you enjoyed this video. If you learned something, leave a like. If you have any questions, leave them in the comments and I'll make sure to reply. And I hope you have a good day.